Fg, the x component, the y component, that's it, and friction. That is a free body diagram. So, in other words, you are doing this. I'm moving the object. We want to find the minimum force. The minimum force is this, to move the object. So, what will be the forces acting along x when you are not moving the object? Along x. Fx, f cosine theta, minus the friction. What type of friction? What type of static? First case, second case. If it's the minimum, if you are looking for the minimum force to move the object, will be the first case or the second case? Can you see the second case, what's said here? Fx max always will be equal to the minimum force to move the object. So, which is the critical value, minus Fx max equal to 0. F cosine theta, I am looking for this F, but I don't have Fx max, is equal or minus Fx max. What is Fx max? According to what I said there, if it's given the coefficient of friction. Mu s Fn, or mu s n. So minus mu s, normal force, equal to 0. Do you have the normal force in this situation? What will be the normal force? How can we find it?
Is it 100?
No. You are pushing downward. So how can we find any particular force in physics? What did I say? This algorithm. So if you don't have, you have to follow the algorithm to find the normal force. What will be the normal force? Along x or along y?
Along y.
Along y. What are the forces along y? Normal force minus mg minus f sine theta equal to 0. Is that correct?
Yes.
So what will be the normal force then from here? So now I can substitute f cosine theta minus mu mg minus mu f sine theta equal to 0. I can move this to this side and I can factor out f cosine theta minus mu sine theta equal to mu mg. Is that correct? I distribute it. I move mu mg to the other side as positive. Then I factor out f, which was what I am looking for, right? And then I divide by this. And this is the minimum force to move the object. In this particular case, will be 0.3 times 10 times 10, let's say, gravity, cosine theta, cosine 37, minus 0.3 sine 37. Get the force. See somebody have the calculator. I got 37.47. Divided by cosine 37. Do you use a degree mode?
Yeah.
Minus 0.3 times sine 37 goes equal to parentheses 48.53. Good. All right. 48.53 Newton. Let's say 49 Newton. 43. This is the minimum force to move the object. Under what condition you never will move the object? Under what condition you never will move the object? Hmm? Yes, no, but I mean, even if you have a force, there will be a force of less, you never will move the object, less than this. But under what condition you never will move the object? So look at the denominator of that equation. So in order for, I mean, what can be a condition that never you will move the object? When this is undefined, right? The denominator. When the denominator is undefined? When this is equal to 0, right? When cosine theta is equal to mu sine theta. What will be mu? Which is cotangent theta, right? When the mu is the cotangent theta equal to cotangent theta, you never will move the object. So will be undefined. I mean, you never will have a minimum force possible to move the object under that condition. Okay, how can I find now if I, instead of that force, I applied, let's say 60 Newton, find the acceleration. What do you do? B. If I applied, let's say 60 Newton, find the acceleration. What can I do? Which Newton law you apply? The second law. What will be the second law according to my free body diagram? Tell me.
The sum of the f of x.
Which is?
F of x.
Fx, which is f cosine theta.
Minus
right?
friction.
Minus the friction. How much is the friction? Mu. And the normal force. What was the normal force? By the way, this is mu s or mu k? Mu k because it's accelerating now. And what was the normal force before?
mg plus f sine theta.
Mg plus f sine theta. Since we know F now equal to ma, so the acceleration we divide by the mass. And this will be the way to find the acceleration. So you know now that the force has to be greater. So let's say 60 Newton cosine 37 minus 0.2 times the mass times gravity plus f sine theta divided by the mass, you get the acceleration. Any question? Approaching. So what is different from what we were doing?